Standard penetration soil testing. The stability of every structure depends on the ground it was built upon. There are many examples of projects which disregarded the surface they were built upon, some with disastrous consequences. That is why geotechnical investigations are so important. If the site conditions are not properly characterized, the resulting foundation will not be properly designed for the site. Investing in the proper investigation up front saves a great deal of time and money down the road in project delays and cost overruns. In this context, the words of Professor Stuart Littlejohn in 1991 ring true today. You pay for a site investigation whether you have one or not. One of the ways soil is characterized is by the method of standard penetration testing. It was developed in the United States in the 1920s and involves hammering a split-spoon sampler into the ground using a standardized driving sequence. The test is widely used and is a relatively simple and cost-effective method of estimating shear strength, bearing capacity, and compressibility of soils. Soil sampling is an important part of the standard penetration test. This is accomplished using a split-spoon sampler at the end of the sampling rod. A split-spoon sampler is typically a 24-inch long, 2-inch diameter hollow tube that is split longitudinally. As the sampler is hammered into the ground, it gets filled with a disturbed soil sample from the depth of the sampler. When the sampler is withdrawn, the technician splits the casing into two halves, visually inspects the soil, and may touch the soil and rub a sample between the fingers to assess the soil fineness. The technician then places the soil sample in an airtight bag to be sent to a laboratory for analysis. Analyses such as density, grain size, and moisture content are used to characterize the soil. To perform the standard penetration test, a borehole is drilled to predetermined depths. At each depth, the split-spoon sampler is lowered into the hole and driven into the ground with a series of hammer blows. For each blow, the standard weight of the hammer, 140 pounds, is dropped 30 inches. The test counts the number of hammer blows it takes to advance the sampler 6 inches in 3 successive intervals. The first 6-inch interval is called seeding the drive and is not factored into the calculations. The final 2 intervals determine the standard penetration resistance, or N value. If it takes more than 50 blows to advance the drive through the 12 inches of the test is discontinued and drilling to the next predetermined depth is resumed. If drilling is no longer possible, drilling refusal is said to have been reached. The engineer will then have to decide whether to stop the drilling operation or switch to bedrock coring. Geotechnical engineers use the N value, in conjunction with other soil data, to estimate soil shear strength, bearing capacity, and potential for liquefaction. A higher N value signifies a denser and stronger soil, requiring more blows to penetrate. The standard penetration test is a valuable tool in geotechnical engineering for assessing soil properties. The laboratory analyses conducted on the soil samples are used along with the N value to provide a more complete picture of the soil characteristics for the purpose of designing safe and enduring structures.